specifically, I want to talk about an environment that you could imagine where all of the counting numbers that exist on a number line instead exist within a spectrum. So, in the sense that they exist within a spectrum, as opposed to their traditional understanding, which is on a number line. This is just by contrast, a space. If you think of all numbers in a spectrum, you're thinking of all numbers in a space rather than in one single space and in one single group under one group heading. And that group heading is numbers. And the space that I'm talking about and the spectrum I'm talking about would be titled numbers, as opposed to the way that we traditionally think of numbers, which is as separated instances or defined instances, or instances that have a point and have an objective point and are particular and can be or definable as a specific or a particular. And really, the word particular is as particular we can get in specifying a different definition, and that's also why we say that's a good description for a particle, because a particle is like the smallest thing that you can still define that is still an objective observable point. And an observable point is what we use. A point is what we use to designate all the numbers on the number line to represent them as objective definable instances. But what I'm telling you to do is to ignore that existence of numbers, and that existence of numbers is objective, and to instead try to understand the subjective existence of numbers and what that would look like. And I'm saying the first thing you got to do, or at least a direction you can take it to understand it, is to view that all numbers are in a single space under the heading numbers. And if they're all in a single space under the heading numbers, they go from, well, think of the number line as it goes to from 0 to infinity, but just understand that all the numbers are not distinguished by points. And so when you say that they're not distinguished by points, at that point you are not really recognizing that they are distinct at all. And so it's really difficult to say what the existence is of 7 and 8 and 9 when they are on some sort of number line, but a number line that is not represented by points. And what I'm talking about is not a number line, but it is a space from 0 to 1, or a space within a spectrum. But the specific spectrum is the spectrum of numbers. And so the spectrum of numbers goes from 0 to infinity. Positively, it goes from 0 to infinity positively, and that's what I want you to consider, is the half of the number line that is positive. But so one of the first things you'd have to consider, or one of the first questions that somebody would say is a problem if you're just trying to have all the numbers on a number line, on the positive number line, be a spectrum, is that a spectrum goes from 0 to 1, but all the numbers on a positive number line go from 0 to infinity. But I'm saying that the infinity that they go to is just representative of the infinite elements that are within a spectrum. So the infinite elements within a spectrum. And more importantly, infinity is the last number, is it not? Infinity is the last number. So even if I'm saying that you have to equate 0 with 0 on a number line, subjectively and objectively. Objective 0 is a point that designates 0, but subjective 0 is but I'm saying that subjective 0 is the beginning of it, because the beginning of all spectrums is 0. And so the beginning of this spectrum is 0, and that's one of the bookends of the spectrum numbers. And then the other bookend of the spectrum numbers is infinity, when it's supposed to be 1, because spectrums go from 0 to 1. But you have to consider that the last point of a spectrum is also the second bookend of the spectrum is also the last point left to right, if you designated the 0 to be first. And And what I'm saying is, and since the bookends of the spectrum can be, both of them are either first or last. They're both last or first and have the properties of being both first and last. The number spectrum that I'm setting up, the left to right is no different from the right to left, and so infinity is basically the same as 0. And if you say that infinity, or the very end of numbers, is the starting point and 0 is the ending point, because this is what's different. One of the things that's different about a subjective view of numbers, for the sake of argument, the environment that I'm creating, is that the left to the very end, infinity to 0, would be the same thing as 0 to infinity. And the reason that you can say that infinity is like 1 is because within any spectrum there are infinite elements, even though we say that the end part of it is even though the end part of it is 1 or 100% as far as numbers are concerned. But the end part of it is from like an empty to full kind of thing, the spectrum that I'm talking about. And it goes from empty to full, where full is like a 1 or a 100%, or empty is a 0 or a 0%. And so picture a glass of water, and then consider that full is where the water is even with the very top of the glass, and empty is bone dry. And so any filling of water between empty and full is some consideration of the spectrum, the entire spectrum from empty to full, where empty is 0 and full is 1 or 100%. But there are infinite elements, meaning that there are infinite possible levels of water between empty and full. And also, every measurement that you make between empty and full is both empty and full at the same time, because the only measurement between this spectrum of entirely empty and entirely full that is not full is empty, and the only consideration of this spectrum that is not empty is full, because anything in between that is at least some percent or slightly full or slightly empty. And when you say the glass is half full or half empty, that's partially explains how at halfway it is both half full and half empty. But at 25% full, it is both half and empty, or it is both full and empty, meaning that it's 25% full and 75% empty. But that is 3/8 full is the same as 5/8 empty, but any consideration is both full and empty on your filling of water. Any filling of the glass between empty and full is a different consideration of a point on the spectrum, but they all have to be percentages, and more specifically percentages of both positive and negative, or both empty and full, both of the thing and then the opposite of the thing that is defined by the spectrum. And in this case, the thing and the opposite thing defined on the spectrum is the emptying and the filling of a glass. So picture that the same thing is happening with numbers, but infinity, then all you have to do is understand that infinity is last. It is the last element of this spectrum of 0 to infinity, and it is a spectrum that you can consider. And then so you're thinking about how any point that you take out, if you take out like 40 on the number line, that is 40 away from 0, and like infinity minus 40 away from infinity. Which is something that you're not allowed to do, mathematically speaking, because infinity minus any number, I believe, is infinity. But that doesn't explain why infinity is written differently from infinity minus 40. Infinity minus 40 is written infinity minus 40. And it's not like, I'm just saying that we already write it a different way, so it's not like you're not allowed to not explore why it's written differently rather than equate everything to infinity. But, or that, anyway, that there's like, you can explain it differently. But, so I'm saying that infinity is like 100% in this environment, because we're talking about numbers subjectively. And 0 is 100% also, but from infinity to 0, it's 100%. And from but from 0 to infinity, if you're considering that direction and saying 0 is the starting point, it is 0%. And so infinity is something like full or 100%, but really specifically it is last because it is the last number and 0 is the first possible number as far as the spectrum of numbers is concerned. And then all of the negative numbers are overlaid with the spectrum, but they're the reverse direction of whatever. So if you defined 0 to infinity to be the first direction, then you use all the negative numbers within the same spectrum and then as the inverse of the original ordering that you did. And then that inverse is from infinity back to 0 because those are the negative numbers because the space that you're considering has to be negative and positive. And so the reason ultimately, and I'll expand on my argument for the numbers existing this way. The reason that I want to look at numbers this way is because I believe that the operations multiplication and division are better seen as being carried out within a spectral space or a subjective space rather than an objective space. And so to understand the root of multiplication, I believe you have to understand the way that numbers exist subjectively, meaning that the way that they exist as spectrums and the way that the way that numbers exist as spectrums, the same way that colors exist definably within a spectrum, within the visible spectrum, but they exist as their own subspectrums, their own definable instances within a spectrum, or they exist as their own infinities within an infinity when you consider the way that colors are categorized on the visible spectrum. And I want to do the same thing with numbers. I want to categorize numbers in that same way, the way that they would exist as subspectrums within a giant spectrum, which is something that we see that we can do, and you can reach some level of definability because we define categories within the visible spectrum. But what I'm saying is if you can get to a great enough level of specification of categories, of numbers as categories rather than as points, or numbers as spectrums rather than as points, or numbers as waves rather than as particles. I'm saying that each point within each number as a point within a spectrum rather than as a point within a number line, which is not really a point within a spectrum. It's only categorizable. It's only a space. It's only a wave. It's only a wave as opposed to a point. So it tells you why, or it would be an explanation, or at least a way of putting words to why something is a particle and a wave at the same time. It's a numerical backing for it. It's the numerical equivalence for saying particle and wave at the same, that a particle is a wave, would be seeing that every single number exists as a wave the same way it exists as a point. And that's what every single number exists as when you lay every single number within a spectrum and call it the number spectrum, and understand that left to right it is 0 to infinity and right to left it's infinity to 0. And it can be 0 to infinity rather than 0 to 1 because it's 0 to 1 or opposite to another opposite where those opposites are interchangeable. But it's 0 to 1. It's 0 to infinity the same way that it's 0 to 1 because infinity is last and 0 is first in the environment that I'm proposing, but it's possible for consideration. I'm just telling you to put them all in one space. Put all numbers in one space the same way that they're seen from the perspective numbers, the same way that they're all an element of a greater level of intelligence, the same way that they're all an element of numbers, and so one out of infinity numbers rather than that they are distinguished values. So I'm telling you to consider numbers in the sense that none of them are distinguished values, but in the sense that they're all a wave rather than as a particle, meaning the sense that they're all relative to 0 as opposed to relative to 1, because in the sense that they're all relative to 0 is the sense that they all don't have separated values, meaning that their value is 0. So in the sense that all numbers are relative to 0, or more specifically, since I'm talking about the multiplication exists within a spectrum, that all numbers, 0 times all numbers is 0. And so I'm saying that is kind of the sense in which they're all relative to 0, is the sense that they're all equal to 0, but that is with regard to value. And so with where they're relative to 0 is that they are all 0, meaning that they have 0 value. But where they're relative to 1, they all have value. Where they're all relative to themselves individually, they all have individual values. But where they're relative to 0, they all have the same value and are all equal to each other. But where they're relative to 0 is the way that you consider each of them within a subjective space, or within a space at all, and within a space at all, and the way that they exist infinitely, the way that they exist as a wave. But the way that you consider them that way is as an element of a greater set, as opposed to the only element of a set, like, because they are a whole, or they are an integer. They're an integer and they're a whole if they are considered as a particle or as a point. They're a whole because, and the word integer comes from Latin meaning whole. It's a whole, it's a distinguished unit rather than a fractional amount of a larger group. And in the sense that each number is a fractional amount of a larger group, they exist as a space within a space, or they exist as a section of space, or a wave, or like where a wave is the consideration of infinite possible elements. But I'm saying that each number as a wave has its own subspectrum that it occupies within the giant spectrum that is the spectrum numbers. And the subspectrum that it occupies is the wave that it is, so the wave of 5. And I want to do this because if you can allow yourself then to consider that numbers, the way that they are laid out subjectively, can have values of different numbers. If you really break down what the rules of multiplication and division are. But I would do that in order to try to figure out what the prime numbers are, and that is my goal. And I'm saying that to understand the prime numbers, you have to figure out the way that multiplication is ordered, and the way that multiplication is ordered is something like whatever the order is for every single number, the way that it exists multiplicatively instead of additively, because the way that every number exists additively is as an object. The way that it exists multiplicatively is as a subject. But the fundamental theorem of arithmetic, and I didn't look it up, and it might be of algebra, but I think it's of arithmetic. The fundamental theorem of arithmetic is that every single number has a specific combination of and integration of prime numbers. So 24 is 2 times 2 times 2 times 3, and 25 is 5 times 5, and 26 is 2 times 13. But every single number is a different combination of prime numbers, is a different one of those, and no two are the same. And if you could understand the order of multiplication, you could understand whatever that order is that distinguishes all those numbers that way, because every single number is distinguished multiplicatively the same way it's distinguished additively. It's distinguished subjectively the same way it's distinguished objectively. It's just distinguished subjectively in an entirely different way, and in a way that is sort of void of pattern and counterintuitive to language as we know it. It's something like the negation of language and the negation of pattern, but that's what an infinite space is. But it isn't way out there to try to consider the way that numbers exist subjectively, because we can, to some degree, pattern and organize an infinite space, and that is through creating subspectrums or dividing points within a spectrum that we've already defined. And you already see that that's possible when people create green as a subspectrum out of the visible spectrum, because green contains infinite elements the same way the visible spectrum contains infinite elements, but you can categorize the visible spectrum that way. So think about the way that colors are organized on the visible spectrum, and then understand that the visible spectrum is neither negative nor positive, meaning that from red to purple is not negative or positive, the same way that purple to red is not negative or positive. Even though purple to red is the opposite direction, you can consider purple to red to be the original direction. Or if I'm talking about equivalently the visible spectrum to the number spectrum, red at one end, or low frequency at one end, to high frequency at the other end, or to purple at the other end, is the same as 0 to infinity. But purple to red you can also consider to be the same thing as 0 to infinity if you want to, because that would be 0 is wavelength or low wavelength, and infinity is high wavelength. Or so you can consider the 0 to infinity to be either one, and 0 is the beginning and infinity is the last, because infinity is the last number. It's the last element of numbers. That is one of the things that infinity is. Infinity is last. It is last, even though it's infinity. And the same way that it is last is the same way that the last element of a spectrum is last. And so therefore the consideration of all numbers on a spectrum is a viable consideration. And so consider that within the visible spectrum you have red organized and you have purple organized. You know the barriers between red, orange, yellow, green, blue, violet. You know all the barriers between them, and you can even create more barriers if you want to. You can go halfway between red and say like red, orange, and whatever, darker red, like darker red and red, orange. And then you can do halfway between oranges, like the half of the orange that red bleeds into, and then the other half of orange is the half of orange that yellow bleeds into. But consider that orange is being bled into by red and yellow, while for all of the elements that we consider to be orange, so that the spectrum that is considered with orange, which is infinite shades of orange, is half a spectrum of orange red and half a spectrum of orange yellow. And then at the very middle orange, or the defining element of orange, like the very middle of the spectrum, the most defining element and also the most undefining element, and it's the most defining element objectively, because that is what we objectively consider orange to be, but it would be the most undefinable element to the other oranges in the group because it is the most intersectional of all of them. It's the most intersectional of all of them because it's in the middle, and it's the most archetypal orange, but it has authority over all other oranges because it decides what orange is. So to the rest of the oranges in the group, or all the other infinite shades of orange, the middle orange has the greatest authority, and all of the other oranges are subject to it, and that is the subjective space orange. And that's what I'm saying is the wave orange, where the point orange is like considering the middle orange to be the defining element orange, or the way that we consider it objectively. Or if we were just to consider the section orange as a point, which is the same way that the same thing that you would call an event in space-time, where an event is like an occurrence, but it's an occurrence over time, meaning like it's an action and took place over several frames of time, but it's just considered to be an event or one thing that took place. Like the breaking of a glass is an event in space-time, even though it took a number of it was an action and took a number of frames within time in order for it to occur. It's just one event, and you would consider orange the group to be one event or one objective thing just by considering the entire spectrum at one time. So any subjective existence like that is sort of like infinity within the group, and one objectively or outside of the group, or is a wave subjectively while being a particle or a point objectively. But so orange has yellow, like, because red and yellow are the levels of categorization that are the same as orange, and so are the two defining categories on either side of orange, because that is the order that we've given to them. But that is red, orange, yellow is the same as yellow, orange, red. In like neither one is better, because you can consider the opposite direction the same way that you can consider you can consider the red to yellow to be the same thing as the yellow to red. But what is important is that red and yellow are the defining categorizations on either side of orange, and orange is in some way defined by both of them. But the very middle and the archetypal orange is the only orange that is 50% definitive of red and yellow at the same time, because every single other element on orange, like 25% of the way left to right from the spectrum that you consider orange, that is going to be like that one's gonna be just red and that one's gonna just be red and a red and orange mix. It's not gonna be a red and yellow mix, but you have to consider a point where red and yellow are mixed, because those are the two defining elements of the category orange, the two defining categories of the category orange, and the only place they mix is at the most undefinable or definable or archetypal or most intersectional or most relative or most representational orange, right in the middle. Most average orange, right in the middle, is the only place where the red and the yellow are considered to be, would be in the same place, or at least, yeah, where they're considered to be in the same place. But so now consider that categorization of colors, that you have red, orange, yellow, green, blue, violet, and that each category is a spectrum, but is like, as long as you consider the infinite shades of green that are designated by the category green, you understand that green exists as a wave. But if you just consider green, the name, the title, the way that you can look at all infinite instances at once and consider it to be one definition, that is how green exists objectively, or as a particle. That's how it exists as a particle. So now do the same thing for numbers, wherein the numbers are 0 to infinity, or the integers are 0 to infinity. And so look at the number 5, and then consider that 5 is bookended on either side by 4 and 6. At least that's the only way that we know how to define that existence, that 5 is bookended by 4 and 6. So you have to, so you're considering all the numbers the way that they exist as waves. And the way that 5 exists as a wave is not as a point, but as a space. And the way that 5 exists as a space is by the space that's designated between 4 and 6, if you could designate 4 and 6 to be recognizable points in any way. So 5 is a space between 4 and 6, and because you're considering the subjective part of it, you're considering how 5 is a space between them rather than that it's a point between them. So consider a normal number line, and then just consider the removal of the 5, so that all that you have is a space between the point that's designated 4 and the point that's designated 6. And that space is the space 5 rather than the point 5. And the space 5 is the wave that is 5, and it's bookended by its categorizations within an infinite space, other subspectrums 4 and 6. And the only element that contains both 4 and 6 subjectively is the most defining 5, which is the point in the middle of the space between 4 and 6. And the point in the middle of the space between 4 and 6 is 5, and would be 5 the same way 5 is considered as a point. It's just that that point isn't there because we're considering 5 as a wave. So rather than considering the point 5 or the defining element 5, you're considering 5 as it is representational of the entire wave 5. As it is the most undefining element of the entire wave 5, and everything within the space from 4 to 6 that is the wave 5 is intersectional to this middle 5, because it's the middle 5. And it's really like a pyramid, and it's a pyramid it's like a pyramid where you're considering the top of the pyramid, or the most archetypal element of the pyramid, the one that all other manifestations of the pyramid descend from and are interconnected beneath. Like the most archetypal element is something that is best considered as the beginning of a tree, from which all, like the base of a tree from which all the branches stem off of, or the very beginning of a tree, or like a factor. You consider a factor tree and consider like 72, and then the way that that's factored out in the tree that you make, like everything is collected into 72. Everything is collected into 5 if you're considering the wave 5 or the subspectrum 5 that is subspectrumed off as its own instance within the entire spectrum that is numbers. So I'm saying that you have to consider the entire spectrum that's numbers the same way that you consider the entire spectrum that is colors. And when you're doing that, you can designate subspectrums for all of the numbers, and those subspectrums are bookended on either, like 5 is bookended on either side by 4 and 6, and 4 is bookended on either side by 3 and 5. And the way that you consider 4 as a wave, as bookended by the categories 3 and 5, is by taking out the point taking out the point that we would consider to be 4, and not considering it objectively, but as a wave, but as that, if that point was negated, so that it represents the undefining rather than the defining element of it. That is, represents the undefining element of the wave 4. And so it's intersectional to everything within that space. And so the space 4 is from 3 to 5, and then the middle point that would be 4, that's the most undefining element, is the only thing that contains 3 and 5, and is the only point then that is intersectional of both 3 and 5. And I would go even further, since this is the environment that I'm setting up, and I'm explaining that multiplication exists subjectively. Like the point that 4 is, that designates the what is relative to both 3 and 5, is as a negated point, this very middle, like 4, the most intersectional 4, which is different from the point 4 or the value 4. The most intersectional 4, or the wave 4 in the middle, can be designated as the collection 3 and 5, or the mixture 3 and 5 at the same time, which would be the same thing as the product 3 and 5. So at the point that it's the mixture of the point 3 and 5. So I'm saying that if you're considering numbers as they exist subjectively, they have no values, and so you have a lot of artistic workarounds. You have a lot of you can interpret numbers differently, and you would come to the conclusions at some point that, or you would come to the conclusions of making numbers to be different values than what they actually are. But they would be different values because we're considering numbers as they exist as waves, but not as their actual values. So the 4, the undefining 4, that is the collection, the intersection of 3 and 5, and is the only point that is equally intersectional of 3 and 5, is what is supposed to represent, if to me, the product 3 and 5. So it represents 15. But 15 is just a 1 as long as it's considered a product. It's not a 15. And every number that's considered, because you consider a product, or 2 times 4 is 8, or 9 times 2 is 18. Whatever product you consider, the 18 or the 8 is just a 1, the same way that 3 times 5 is a 1, because it represents like a group of 15, but the way that you see 15 as a group. And so any product that you come up with is a 1, the same way that any definition you come up with within an infinite space is 1. And that's partially why multiplication exists subjectively, is because the designation of a product should be one thing, or should be a mixture, and a mixture is percentages, and percentages, it's a mixture of 3 and 5, of something called 3 and something called 5, and void of their values. So it's not important that it would be like 3 and 5 would be like 3/8 or 5/8 of a whole out of 8, out of a total of eighths. What's important is that they're 2 different names and a mixture of 2 different names. So 3 times 5 is a product 15, and any product that you designate as a 1, like subjective space deals with 1s the same way, like time frames are all 1s, like 1 second, 1 hour, 1 year are all 1s, because they're different units of measurement, and a unit of measurement is a 1. It's just that any different unit of measurement that you consider is a translation of a language into a different unit, but it's all a 1 as long as you're not leaving just calling it a unit, as long as you're not going into quantifying them, as long as you're only going into what it means that thing is 1. So I'm sort of saying that all the different products that you can come up with, or all the different mixtures, which are just percentages of 1s, are sort of like different units of measure. So like because they're all 1, like a product of 15 and a product of 16 and a product of 17 are all 1s, and are all the ways that numbers should be seen as 1, or are the ways that numbers exist multiplicatively, because the way that numbers exist multiplicatively is subjective, but the way that they exist additively, or that they have value, is objective. So the 4, the undefining 4, you want to consider to be 15, and the 5 as a wave, which is between 4 and 6, you want to consider to be the product of 4 and 6, which is 24. And so you do that for all the numbers, and then you try to figure out, so I want to do that, or I did do that, and then you figure out what the pattern of numbers is telling you. And if you're getting closer to prime numbers, then you're headed in the right direction, or you have a theory that's possible. And what I find when I did that is, if I just considered that order of numbers, like is that, so 4 as the undefining one is 15, and then 5, the next one is 24. So the order that you get for the numbers, where the numbers used to be defined points on a number line, for 1, where 1 used to be, where now you're just considering the wave 1, then that number is the product of 0 and 2, which I wouldn't really know what to say about that or call that. So that would just be a question mark. And then 2, where that used to be, would be the product of 1 and 3. So the number you get is 3. And then where 3 used to be is the product of 2 and 4. And so that's 8. And where 4 used to be is the product of 3 and 5. And so that's 15. And then the next one is 24. And then the next one is 35. And then the next one is 48. The next one is 48. So you want to look at that pattern of numbers and then see if you're getting anywhere close to prime numbers, or if you see that there's anything interesting. So generally the pattern, at least the way that I consider it locally, where you just consider what the new numbers are as waves, as opposed to the way that they exist as particles. And partially I'm saying that, like, the way that 4 exists as a wave, apparently the name that you give to it is 15. So it's kind of like a renaming, or a consideration of an equivalent term for the same thing. And so I'm saying that, like, where 4 used to be, it's a 15, and so that's like a different unit of measure of a 4 somehow, but it's a translation of 4 into a 15. And you don't want to take any of it really seriously until you find something actually. But I just happen to be explaining the process to you, and explaining, because it is entirely ridiculous to say that numbers are something other than the numbers that they are. But I'm just trying to do it to find prime numbers, and like explaining the process, so that if I do ever actually find prime numbers, it's like this documented way of me getting to it. But I'm not going to consider that any of this is true. Right now, all I'm considering is here's an environment. I'm proposing if all numbers existed on a spectrum, and the spectrum is 0 to 1, 0 to infinity, as in all the numbers exist as a space, as a connected, every number is equal in one element of a space, rather than that every number is separated, because every number is separated objectively, and that's the way that we consider numbers at all as it stands now, the way that we consider them objectively. But it's time for us to consider a numerical equivalence to quantum mechanics, or like a numerical equivalence of considering elements within an infinite space, like a numerical or mathematical backing for it that science is already delving into, or a philosophical backing for the explanation of infinite space. And really a philosophical a mathematical backing of talking about elements in an infinite space would be philosophical, and it would be something like a bridge. If you were to figure out what the prime numbers are, my belief is you have to really consider the philosophy behind it. And if you did figure out what the prime numbers were, you would create a field of study that is a point of reference between philosophy and mathematics, because the consideration of mathematics and numbers philosophically is the consideration of them subjectively, as opposed to physically and countably. But so the pattern that I got when I go through this process and consider that every number is the defining element of the two numbers on either side of it, where each one is designated by a spectrum, and the bookends of the spectrum are the numbers on either side of it, and pretty much, so like, let me tell you at least a little bit more No, that's not what you're interested in. That's not what you're interested in. You want to hear about the pattern that I figured. The pattern that I figured out was where 2 used to be is 3, where 3 used to be is 8, then 15, then 24, then 35, then 48, then 63. And so then you consider that pattern, like what is, you contrast that with the original pattern, which is 1, 2, 3, 4, 5, 6, 7, 8. And I found that the difference between where 2 used to be is a 3, right? So where 2 used to be as definable is a 3 undefinably. And so the difference between 3 and 2 is 1. And then the next one is 3, and now it exists as an 8 undefinably. And the difference between that is 5. And then where 4 used to be, now it is a 15. And the difference between 15 and 4 is 11. And so the differences of the original set 1, 2, 3, 4, 5, 6, 7 and the new set, which is brought about by the products of the bookends of the spectrum for each one, the pattern of the differences is 1, 5, 11, 19, 29, 41, 55. And those are exclusively prime numbers. And also, well, I mean, they're not exclusively prime numbers. They're almost exclusively prime numbers. 55 is divisible by 5 and 11. But if you continue that pattern on, you will find that everything that is not prime within that set of numbers of those differences is divisible by 5 rather than divisible by 2 or 3, or it's divisible by 19, but it's divisible by, it's like divisible by 5s and 19s only at like the 19th, like it's divisible by 19ths only in the 19th element that's considered, which is interesting. So that does create numbers that are divisible by something other than prime numbers, this pattern, but it is almost entirely prime numbers. So it's like something, so that would be an indication that I like the direction of where I'm going with it. Because also so that was the consideration of the differences of all these pairs of numbers. The consideration of the addition of all of them is, so the first one where a 2 used to be, definably, it exists as the multiplication of 1 and 3 undefinably, and the difference of that is 1. The sum of that is 5, and then where the 3 used to exist definably, it exists as a product of 2 and 4 undefinably, or exists as an 8 undefinably. The difference between those is 5, and then the sum of those is 11. And then the sum of the next pair, which is 4 to 15, is 19, and then the sum of the next pair, 5 to 24, is 29. And what you find is that the sum creates the exact same pattern as the difference. It creates this strange, interesting pattern that is mostly prime numbers, or this line of numbers is mostly prime numbers, which is 5, 11, 19, 29, 41, 55, 71. And but it creates the same thing. It's just indexed 1 to the left, as opposed to, so the 3 and the 2 subtracts to make 1, but it adds to make 5, and then the 3-8 pairing subtracts to make 5 and then adds to make 11. So the subtracted set is indexed, so the added set is indexed 1 to the left of the subtracted set, but it is the same pattern. It's just indexed 1 to the left. And that is also a really good indication that I like the direction I'm headed, because you start to create patterns that are definitive of more than one operation. Or if you have a set of numbers like 5, 11, 19, 29, 41, 55, 71, and the way that I arrived at it, it tells me that I've created a set of numbers that is, in the way that I understand it, the way that I arrived at it, relative to both addition and subtraction. So it's a set of numbers that is relative to addition and subtraction, at least with consideration of the contrast of the two sets of numbers 1, 2, 3, 4, 5, 6, 7, and then the product set of numbers 3, 8, 15, 24, 35, 48, 63. But so it would be, so you find that set of numbers, but that obviously isn't the only thing to consider here in considering numbers as they exist as a wave, because you have to consider that like a number is like, because you're considering a spectrum from 0 to infinity. Anything that you define between 0 and infinity is a spectrum. And so if you consider that 4 is bookended by 3 and 5, you also want to there's any spectrum within it is something you can consider. So you can consider the spectrum 3 to 4. And by the logic that I came up with for defining a point between these spectrums, there's like any point between, like a point between 3 and 7 then is whatever is the point halfway between that. 5 is also definitive of 21, you know, and the thing that I'm considering. I'm just proposing this in the way, I'm proposing this saying that the best way for you to define 5 is to understand that it is bookended by the most specific categories that bookend 5 is 4 and 6 rather than 3 and 7. But if you're allowing for this subjective space to exist, you have to consider what it would mean that you have this certain, you have these values that exist for 5 extended out even further, like 3 and 5 is 20, 3 and 7 is 21, and then like but because, and 21 would be superimposed over where the 5 is, because the 5 would be the 5 would be the most undefining element. But you could also consider, because I'm considering the spectrum whole numbers, you could also consider the spectrum integers, which would include positive and negative. But yes, you could consider the spectrum integers. That does include positive and negative, but I guess I wouldn't want to go into that at this point because that would be confusing, because I'm just considering numbers where it's positive and negative overlaid with each other. The spectrum integers would also be positive and negative overlaid with each other. It would just be like double the size of just a spectrum that was just natural numbers. But as long as you're just considering 5 to be most specifically defined by the categories on either side of it, 4 and 6, I'm saying that would be the set of numbers that you would want to look to first in order to figure something out about what prime numbers were or what the order of multiplication is. And really, in trying to figure out what the order of multiplication is, you do more than just consider ways to figure out new patterns of numbers. You consider what multiplication is objectively or truthfully from everybody's perspective, and try to understand what exactly it is and the way that it's distinguished from all other operations, and especially the way it's distinguished from addition. You have to do that in order to figure out what it would be counted in. And if you could figure out what multiplications are counted in, then you're doing something like understanding the order of products. And so this is just the spectrum. All numbers on a spectrum would possibly be a way of helping me understand it. But something that's interesting about the points 2, 3, 4, the points as they are, like 5 is 8 and 4 is 15 and 5 is 24, what I just described to you, where they're bookended specifically by the two numbers that we've given the names to be surrounding 5, like 4 and a 6 surround 5, is that it is every number that the pattern that you get, like where 2 used to be, it's a 3, and where a 3 used to be, it's an 8 as the product of 2 and 4, and where 4 used to be, it's a 15 as the product of 3 and 5. That entire pattern is the square of the number minus 1. Interestingly enough, like 4 squared is 16, but minus 1 is the 15 that I'm designating to be the undefinable for the product of 3 and 5. And 5 squared is 25, and that minus 1 is the 24 that is the product 4 and 6. And so every one of them is also the square of the number minus 1. And to me, that would say something about that. So like the wave 5, the the spectrum that you're designating to be 5 as bookended by 4 and 6 is named 5, is titled 5. It does not have a value of 5. It only has a title. And like it only has I mean, that's the only possible thing it could have, but only a title as understood to be the same as all other titles, which would be some sort of valueless title. I'm just saying the only way that we could start to consider it is consider these titles. And the title of this spectrum is between 4 and 6, just like 5, and would be a name 5 overlaid with a negative direction, because you're considering a positive direction with a negative direction at the same time. And so it would be something like a 5 overlaid with a negative 5. So it's kind of like, maybe you could start to consider that you could start to consider each one of these things as their number squared, but that's a lot more foggy of a explanation. I'm just trying to make a correlation. But interestingly enough, so you can consider the spectrums just between 0 and 1 by the same logic, by the same rules. You can consider the subspectrum 0 to 1 within the entire spectrum 0 to infinity, or from 1 to 2, or from 2 to 3. And then you can designate the half points to be most specifically the points between 2 and 3 are the products of 2 and 3. So like at 2.5, or halfway between 2 and 3 would be 6, halfway between 3 and 4 would be 12, and halfway between 4 and 5 is 20, and then halfway between 5 and 6 is 30. And that series of numbers that you get, that would be halfway between the spectrum of all spaces considered as spectrums, between where the differences are just 1. That series of numbers that you create is 2, 6, 12, 20, 30, 42, 56, 72, and that series of numbers is called the pronic numbers, and the pronic numbers are like the orders of all of products. If you ordered the numbers numerically, like 0 times 1, that series is 0 times 1, 1 times 2, 2 times 3, 3 times 4, but is also each number squared, like 3 squared, but minus the original 3 that you multiplied is 6, and then 4 squared minus the original 4 that you multiplied is going to be 12. But it's the space that's given through the multiplication, because of the multiplication. The added portion because of the multiplication are also the pronic numbers, but so they're dependent on squares. Not important, but anyway, these pronic numbers, like I told you that 5 definably is 5 and undefinably is the product 4 and 6, which is 24. You would also want to consider that between 4 and 5 is 20, and between 5 and 6 is 30. So 5 undefinably also exists between the two pronic numbers 20 and 30, but it exists at a different level and at a different unit of measure, because it's a spectrum that, if you're able to consider the linearity of a spectrum, is half the length of the 4 to 6 spectrum that designates 5, as opposed to, and is half the length of that, meaning that it is just from 4.5 to 5.5. But it then goes from products that we've created 20 and 30, but then when you're considering 5 as being the middle part of 20 and 30, and then you do the product 20 and 30 to get that middle point 5, because 5 is also the intersectional point of those two pronic numbers, but you've already created a product, so it's like a level deeper. You've already created a product to make the numbers that are bookending 5, so it's a level deeper than the 4, 6, 1 already. So the next, you go a deeper level to multiply 20 times 30 to get the value for 5. So 5 has all these different values, which are the middle points of all these spectrums that you could consider within the subjective within the entire spectrum. The middle point 5 has infinite values that you could consider, and infinite and different levelings of them that you could consider. But 20 times 30 to get 600 where the 5 is would be 2 levels deep as opposed to the 24 that you get, which is 1 level deep. But interestingly enough, the 600 that you get that's on either side of 5, if you divide that by the level 1 level lower than it, the 24, if you divide 600 by 24, you get 25, which is 5 squared, which I've already told you about the correlation that each of these 5 equaling the product 4 and 6 undefinably as 24 is 1 less than 5 squared. So it's also the series of numbers that, or the way of considering numbers subjectively, also seems to show you something about how division is defined between levels. And this is just something that I figured out yesterday. But like I'm always trying to figure out stuff like that. But this is like this series of numbers, this 5, 11, 19, 29, 41, 55 is the greatest point of reference that for a series of numbers that I would have reached about considering numbers subjectively in my attempt to link the counting numbers 1, 2, 3, 4, 5, 6, 7, 8 to prime numbers 2, 3, 5, 7. It's a point of reference, and I now have the opportunity to figure out stuff like that because there would be a lot that goes into considering any one point in a spectrum, because any point in a spectrum is a wave and is sort of like a negation of space. Like 5 as a wave is a negation of space, and it as a wave can be considered between 4 and 6, but also can be considered between 3 and 7. It's just that there are, whatever way it's organized, I'm just interested in trying to organize it, but I'm hoping that it could tell me something about like a better way of understanding division, because you can't just understand multiplication and division through language that we've been given and through language that's predicated on physical instances and definitions and separated values. And so I'm just trying to explore what a subjective number space would be, and it's the same thing as categorizing. You have to categorize a 5 and understand that it exists as a wave and exists infinitely in order to understand its subjective instance. And the way you do that is to consider 5 as infinite manifestations or infinite shades, of 5, where it bleeds into 4 and bleeds into 6, as 4 and 6 are categorizations on either side of it. And so when you consider this number subjectively, they are all waves bleeding into each other, especially, and the specific way of understanding them is to say that 5 is being bled into by 4 on the left and then fading into 6 on the right, and it does that. It's channeled into 6. 5 is a channel between 4 and 6. 5 channels 4 into 6, and 6 channels 5 into 7, and that's why you have the term medium, and why that is a channel, because a channel is a subspectrum. There's a band of frequency. It's a band of frequency, or it is a medium. But a 5 is a medium between 4 and 6 because it is a channeler of 4 into 6, while at the same time being a channeler of 6 into 4, because it is a channel. It's a two-way street, but it's a channel. It's still a space, but it's a medium because it's the medium between those two levels, 4 and 6, between those two different designations. It's a medium. 6 to 4 is a medium. 4 to 6 is a medium. And they're channels. They're bands of frequency. So you have to consider every number as a band of frequency or as a wave, and also in addition to considering it as a particle. But especially now we've reached a time in human history where we should really consider numbers in their infinite sense rather than just their finite sense. And so I should write a book about it, or actually demonstrate it through examples. But the podcast is the laziest way that I can do it, because I just talk about it. But maybe that's the only way that I can do it besides writing a book. So I'm talking about numbers the way that they exist infinitely and the way that they exist as waves. So if you consider 0 to infinity, and every number that you could consider as particular, now you're considering to be congealed with all the other numbers. They're congealed because they all fade into and out of each other. the same way that waves would, or the same way that categories within the visible spectrum, all green fades into yellow, fades into green, and then green fades into blue, and they all fade into and out of each other because they all exist infinitely. But the way that they exist infinitely is as ones, they exist as a one, but a 1 5 is as a one infinitely, or as a wave, but it is translated or faded into the next one, that is 6. But that's what time is. That's what time is. It's a fading of one instance or 1 year or one time frame into the next time frame that you can into the next time frame that you also consider to be one, because it's this year, it's the present, and like it just fades into it, and then now you're in the present, and you can only define it as one thing, and that sort of thing. So I'll let you know. I'll update you on if I find any more interesting things about the pattern of numbers, and see if I can get closer to what the prime numbers is. But feel free to subscribe. I don't always talk about math, but obviously you can look around at the rest of my podcast. If you arrived at this page, you understand that I don't just talk about math theory. And they are my own theories, and I understand that, and I take responsibility for them. And and now I'm going to end it, and